Welcome to the STEM Pathways with Rohan Sharma podcast, where we dive into the exciting world of science, technology, engineering, and math. In each episode, we share exciting stories, groundbreaking research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we explore the endless possibilities of STEM. Let's get started. Today I'll be interviewing Devesh Ranjan, who is currently the chair of mechanical engineering at Georgia Tech and is going to be the future dean of engineering at UW Madison this coming fall. How are you doing today?
I'm good. Thank you, Ron, for inviting me here.
Yeah. And thank you for coming on the podcast. So to get started, I wanted to ask what were your interests back in high school? What made you want to do engineering in the first place, and what did you do during your undergrad?
So let me take you on a journey before high school. I grew up on a farm in India. So when you're on the farm, you see a lot of these farming equipments for people are using like tractors, they're using things for irrigation. So I always wanted to build something which can help the farmers because growing up on a farm, I want to see how I can help my parents and other who were in the farming side. So that's what excited me about engineering is like, hey, I learned that engineering is a great thing to do it. And then that went into high school where I was like, oh, if you go to mechanical engineering, that's where they make these things. That's excited me about mechanical engineering in the high school that I wanted to do something in mechanical engineering. And rest is in India growing up, there are only two fields. You either become doctor or engineer. So it was very clear that you had to pick one path. And probably I was very good at drawing biology, but I was never good at remembering things about biology. So my path was clear that I have to do math and physics. So I became engineer at that point.
Yeah. So where'd you go for your undergrad?
So I did my undergraduate studies in India. The school name is NIT Trichy. It's in southern India, state of Tamil Nadu. Uh, it's a school which basically built upon the culture of bringing regional college. It was called. So what regional college means is, think about a state in US, like Georgia, has an institute which is a regional institute which is state funded, but each state has one student from each state of the US coming there in every department. So mechanical will have one student from every state in the country. So that's what the school is. So I was there in southern India. It was an awesome place where I loved to learn, about different things, but also learn about myself because in India, if you know, it's a very different place, northern and southern India, because of the languages we speak there. It's completely different. The dialects are different. So I went to a southern India, a person who can only speak Hindi and English, and there the dialect was Tamil. So I learned a lot about myself, how to communicate and also engage with people in that space.
Yeah. So what were your interests and how did those develop during your undergrad, and when did you decide that you wanted to go to grad school?
Yeah, so in my undergrad second year, I was fortunate to be selected for there's a Rajiv Gandhi Talent Scholar Program in India, which happens. They select people to go and work in, let's say, IIT or ISC Bangalore. In my time, I went to work at ISC Bangalore, where I bumped into somebody who is called the father of nation in fluid mechanics area. So if you think about, if you watch Netflix shows right now about rocket engines, so this person was Satish Dhawan's student. Satish Dhawan is the person who is in charge for the rocket science in India. So his name is Rodam Narasimha. He was my undergraduate advisor. I went and worked in his lab and I had no idea how big that person was till I came to US. Then everybody started telling me how big. But he really exposed me to fluid mechanics and turbulence, thinking about high speed flows, what happens in the rocket science. So my interest started thinking about, how does two fluid mix? How do you think about combustion of different materials? So you can have a hypersonic plane that I can go from Atlanta to Tokyo in 1 hour. So those are the things that interest started when I was in my undergrad time. And then I was looking around when I was thinking about that school, that where I'm going to do it. I ended up going to Wisconsin Madison because the faculty member I wanted to work with at Caltech, he just passed away in 2002. So I went to his student who was a faculty member at Wisconsin Madison.
Yeah. So what was your experience like while getting your PhD, and how'd you like UW?
So I arrived on UW campus on June 16th, 2003. I still remember it was a beautiful summer. I have never seen such a, if I think about a place in the US, that's the first place you went there. And there are two lakes. If you've been to Madison, it's an isthmus between Lake Monona and Lake Mendota. It's an amazing, beautiful place. So I just fell in love with that campus on day one I arrived there. But then came winter, which I again learned about myself more. It's like it was really hard. The first winter was really hard and challenging. So, but when you're 21, 22, you think about these things, experience, which shapes your life moving forward. But the research was absolutely phenomenal. I think I could not have asked for a better advisor than my advisor, Ricardo Bonazza at Wisconsin-Madison. He's a gem of a person who took you as a like and gave a playground that do bigger things. It was not like, oh, just go and design something. He's like, think about what bigger things we can do together. And I learned a lot in his tutelage. It was absolutely best time of my life.
Yeah. So what was your first job out of your PhD?
I had an offer from McKinsey at that point, and I wanted to go into academia, so I took the offer to go to Los Alamos National Lab as a director research fellow. So, director's research fellow is basically a prestigious fellowship which Los Alamos National Labs provide for postdoctoral study at Los Alamos. And I worked there for 1 year before I went into my first faculty job.
And where did you start out as a professor?
So my first faculty role was at Texas A&M University. So I was an Aggie there for 5 years at mechanical engineering department.
And what was your research like right when you started?
So my first couple of years, I was truly focused on understanding the same thing about turbulent mixing, but I also got involved in doing power conversion cycles. So just to give you right now, all our power cycle in this country is either steam cycle or combined cycle, what we used for burning coal or natural gas, whichever way we think about. So I was looking at alternative way of power cycle which can club with the solar energy together. So think about we make a solar tower, but we run a cycle which is much more efficient than the current cycles. And that's what my research was all focused on.
Yeah. So when did you start at Georgia Tech?
So I moved to Georgia Tech in July 2014. So now I've been almost 11 years.
And how's your research evolved from 2014 and now?
So there are a lot of things have happened in my research career over the last 11 years. I continued my research what I started at Texas A&M. So I was still doing things on power cycle, looking at turbulent mixing. But when I came to Georgia Tech, you're in an environment where absolutely phenomenal faculty colleagues are thinking about bigger things. So I went into two new research area because of the amount of people in that space are working absolutely brilliant. So I'll give you two very interesting example of which I never thought I was going to be working in that space. So one of my colleague brings me an idea that we should think about how to minimize the amount of water usage which takes place in making paper. So you use toilet papers, you use all this paper. It takes a lot of energy and water to make papers. So we started thinking about a new process which is gonna do multi-phase forming process. It's called to decrease the amount of water and energy which you'll use to make the next generation paper. This project got funded by ARPA-E. This got funded by DOE, and it only happened because I had a colleague who's an expert in paper, but he knew that I can do these outstanding fluid mechanics measurements with laser-based diagnostics, which will provide us to figure out what happens in these processes. So he's a computational, I'm an experimentalist. It was an amazing group, which we have now done a state-of-the-art next phase forming process in partnership with Kimberly Clark International Paper. There are other companies which are involved in that processes now. So coming from a state in Georgia, if you know about Georgia, Georgia was a paper and pulp state, right? So the economy here was based in doing things in this space. So we really think what we're doing can even start some of the stuff for next generation manufacturing and paper forming and a new way of paper making in the state of Georgia. And it happened just because of people here. The second example is also in a very similar way. One of my colleagues is probably, I'll say, 1 out of 4 person in the world who has this amazing facility called solar simulator. They can really simulate the amount of energy coming from sun and about 100 sun kind of energy. So we were trying to think about concentrated solar power and the power cycle work, which I was still doing at Texas A&M. I brought here. Like, how do you merge that together? Or what are the challenges in that space? So multi-phase area, there's a lot of effort which was going on at Sandia National Lab, and so we got a partnership with Sandia, Georgia Tech in that space to really look at fundamental work which will change the way Sandia was thinking about the power cycle for the solar side. And that happened because of that relationship here.
Yeah. So, Georgia Tech, something that's super special about it is just how many students it has and how many people it's able to teach. And you were a chair of their largest engineering department, the Department of Mechanical Engineering, which I believe had right around 3,000 people, which is larger than the amount of undergrads some universities have in total. So, what was it like being chair of such a massive department and getting to work with so many people?
So I used to say before I was a chair that the best part of my job is to go in the lab and work with these outstanding students who are amazing graduate students and teach in their class. But once I became the chair, I think that the energy I saw of the 2000 undergraduate student and what they were doing in the classroom and outside of the classroom really makes my job so special. I love the opportunity to meet with undergraduate students when they're coming in. I enjoy, going in our invention studio, which is a really big invention studio at Georgia Tech. It's a maker space where student can build things. I go and look at their class in sophomore level. It's like a robotics class, same as first robotics, other thing you have done. But this is a class where they learn from failing in the class. So learn from failure of certain things happening. And then they build things which sometimes has gone and become a company. So I got so excited about the opportunities our student have. And then something hit to me is it would be amazing that every person can come to Georgia Tech, irrespective of what their financial background is. So if you get admitted to Georgia Tech, financial constraints should not restrict you to come to Georgia Tech. So, as in my role of a chair, I really focus my effort and time to doing fundraise from our alumni and others. Is like, can we provide scholarship, fellowship to the student that they can come to Georgia Tech if they have a need to, financial constraints they have to address. And I have focused my time on doing that. And that process really, make you learn a lot more because you go and meet the alumni and then they talk about the stories about how their life was transformed at them when they were at Georgia Tech. And they want to do the same thing for the other student. I've learned amazing things about, what happens in the higher ed. So I'll tell you what really taught me in the long term is like this experience has taught me that higher education is probably the biggest opportunity we have in this country for social mobility. Social mobility of people happen because they go through the college and the higher education shapes that for them.
So, one thing with financial aid is that the fact that there are so many students as well. And then actually, before I say that, I talked to the provost a few weeks ago, Steve McLaughlin, and then he was also telling me like how many opportunities there are for students to come to Georgia Tech in general, whether that's through having tons of financial aid, like you were saying, or having multiple different transfer pathways. How do you think that comes together to form a diverse student body and how that benefits the university?
I think Georgia Tech is right now very blessed. What I say by very blessed is, parents and students like you really look at this as a place where you think, my journey, I'm on my journey of excellence. This is what I always say. Every student like you are on their own journey of excellence. You're looking at a place where you think your journey will be supported and you're going to grow the most. And we are fortunate that a lot of you are thinking about Georgia Tech as your stop in your journey. And that's a true statement because you all are so smart that you have multiple options to go different places. Uh, so Having said that, what my responsibility and where I feel like large school I have to be thinking more, there are still students who might not be prepped as the way you are prepped for the classes. And it's not because they are not smart, it's because they might not be in this right kind of a locality, neighborhood. So we focus a lot on trying to ensure that first generation student, people who might not have their parents have gone to college, can we work with them in through some of the K-12 partnership program that they are well prepared when they're applying for their application here. So we look at those things. And then we also look at, hey, we saw your application was good, but not at the same level as what we think. So we work on the transfer pathway. So that's what Provost was talking about, is a transfer pathway that we would love to have you here, but I think if you get certain grades up in these cases, you will have a real chance to come to Georgia Tech. And we have strengthened our transfer pathways with certain institutions where we know that they have a very strong sets of very similar kind of classes we teach and others, and that helps.
Yeah. So it's recently been announced that you're going to be the Dean of Engineering at UW Madison this fall. What made you want to come back to Madison?
So I used to joke with when you're the chair of the largest school at Georgia Tech, you're always on the list for recruiters for different dean. There are several places which came after me for last 1 year, and every recruiter when it came, I used to say like the only place in North can move me is my alma mater. UW Madison is where my life was changed. You know, who I am today could not have happened if I have not gone to UW Madison. Madison took a risk on somebody like me from India, coming from a village, coming from a background which was very different. But that's not the story of me. That's a story of, even in your back Canada, there are people who are coming from the village in the Wisconsin area. The same I see in Georgia. So there's an inherent thing that my life was transformed when I went to Madison. This is the place which can take me away because I feel so indebted to the opportunity that place has given me that if I can go back and do something and provide the same opportunity to some other student like me, I think that's the best thing I can do in my career. So I'm super excited to have this opportunity to come back and start my job on same day, June 16th, 2025. It's just 22 years after the same day I started my day one at Wisconsin Madison. So I'm really looking forward to this opportunity.
So what are some of the goals you have with Madison, and what do you want to maybe change or improve as dean?
So, I don't think about ranking, so I'm going to give you this. A lot of people think, hey, I want to change the ranking. I don't think about ranking. I think about in terms of impact. What I want Wisconsin to be known as not just a regional institution, but as a national and a global institution of impact in engineering. And that's my number one goal. I also see amazing opportunity. Madison has an amazing med school right next. Engineering and medical school combined can do a lot of amazing things in the area of cancer technology. If you're thinking about cancer research side, you're looking at next generation bio devices that it goes through engineering and med school. If you're thinking the quantum area, we have absolutely phenomenal physics department at Madison. So thinking the quantum engineering area, they have a lot of space to do things. Sustainability, you have agricultural school, you have letters and sciences have so many people in the ethics area. You can start thinking of sustainability area. And then Madison is announcing a new school for, as you know, information technology and sciences. So I want AI to be part of everything we do in engineering. I always talk about this thing that experts with AI fluency will replace experts without AI influency. So you have to be experts and you have to have AI influency. When I say experts, it means you have to have expertise in engineering discipline, but you also need to know what AI influency looks like. So my big goal is to think about, what I call engineering plus X. So you're going to have engineering domain and you're going to have plus X, and those are ethics, AI, looking at sustainability efforts, looking at trade laws, what you can do for IP side. So that's in the curriculum. But I want to change the mindset. I want to do a bigger thing about what I call entrepreneurial mindset in our student and faculty. I want the next big device is not just the research to be done, but translated into companies translated into new, area of bigger and smaller companies, which impacts every county in the state. So there are 72 counties in Wisconsin. I want to make sure every county in the state feels the impact of what we're doing in engineering.
Yeah, so are there any efforts that you have thought of? I know that there's things like Startup X at Georgia Tech that really like helps students
So
just kind of accelerating.
So we're gonna announce the accelerator. So we're gonna announce the academy for. You will see some announcement coming out within 6 months. I can promise you that. So it's in works right now. I'm doing my study right now to understand what are the opportunities we have, but we will see a lot more in that space in the next 6 months.
So for my last question, I wanted to ask if you have one piece of advice for someone who's still in high school or early in college wanting to follow a similar career path as you.
So first I'll say I'll correct something and then I'll give you the advice. Don't follow the path of someone. Build your own path. Build your own path. What you want is you want inspiration to see like if somebody else did it, you can do it. But the big idea which I want everyone to think about is when you're high school is dream big, dream bigger, think bigger. You need to be big and you need to think about bolder decisions in your life. Take some big bets. So don't think about incremental changes or incremental thing. Think about what are the out of the box idea to make some changes. So one advice which I have is if you want to put something is put there is like dream big. And that should be your advice always.
All right then. Thank you for joining me on the podcast today.
Thank, thank you, Rohan.